around us in a rare moment, actually, that we five people are together in the same space. And the space we're in is we're right at the heart of the Vitas laboratories on the Science Park in Oslo. And we're just going to enjoy ourselves, really, and have a conversation about the kind of work that we do, which is very much a living, breathing daily activity for us. And we're so interconnected, whether that's online or in the labs, that we don't really stop like this and talk about the why, the how, the what of what we do. And that's the exact purpose of this little meeting today, is to give all of you a little bit more of an insight on really the science, the technology, the decision making that drives everything that we do at Zinzino. And so, without further ado, I guess we just need to kick this conversation off. And it's on me to decide where to go. And I think that as we're at Vitas, I think it's only right, Thomas, that we go to you first of all. And really, I want to pitch this around, I guess, the common questions that crop up whenever people speak to us and whenever people are interested in what we do. And the test is central to what we do. And obviously, you're the man behind the test. So I'd say the biggest question is, why do we do it this way? Why is it that we use the DBS method, whole blood, rather than the method that other people are more familiar with, which is the red blood cell, the RBC? So if you want to take us through some of that thinking, rationale and reason, that'd be a great place to start.
Yes, I will. So, these RBCs, they are interesting because when we analyze them, we get a long history, 120 days history of what kind of lipids you've been eating. So if you use the plasma fraction, the yellow fraction, we only have like a short time period, like what you had for dinner yesterday. But it's not so interesting, right?
Yeah.
You already know. So the best thing would be to isolate these RBCs from the blood and analyze them. But that's kind of tricky because they are fragile. They will start to leak. They will die. And they are pretty hard to handle. To collect them remotely and ship them requires to ship liquid, which is not so good because it can leak. Mm-hmm. And also you need cooling, dry ice, for instance, which is very expensive. So to kind of make it possible to do this in the real world, we collect whole blood. And kind of it's even better, because what floats in your veins is whole blood, not RBCs. So what your organs are exposed to, your heart, your brain, your bones, are the whole blood.
Yeah.
No? Not the plasma, not the RBCs, right? So it's kind of better. And it's kind of a tradition to use the plasma because it's simpler, because it's not that red, not that viscous, so it's easier to handle in machines and so on. So I think whole blood is a good thing to use. And to be able to ship it, we need to dry it because then we don't have a liquid anymore. Mm-hmm. It cannot leak, right? And when the water is removed, it's more stable. And also the pathogens in the blood will die, like HIV, for instance. So it's also safe to send it.
Yeah.
So I think DBS, dried whole blood, is brilliant. I mean, it's very well suited for a high volume collection of samples remotely and send it to a central lab.
And then, I mean, given that with any kind of tissue, any kind of measurement, you've got to look at how you can control the variance or the difference around the values that you can observe.
Yeah.
And so what kind of processes do you have in place so that you're really narrowing that margin so that you've got confidence in the data that you report?
Yeah. And this is also important because the variance they will add for each step you do. Mm-hmm. You'll have more and more variance. So the fewer steps you have, the better the method, the better the precision.
Yeah.
Right? So, and this also is important when you use whole blood because then you have kind of fewer steps towards the final result, which keeps the method more precise. For instance, it is possible to convert to RBC units using a so-called regression equation.
Yeah.
But this involves some mathematical simplifications, right? And this will add uncertainty. So actually, it's better to use DHA, EPA, and whole blood than converting to the omega-3 index in the RBC fraction.
I think that's a really good point, and I think that's often something that people don't appreciate, is that every step creates an opportunity for things to broaden out in the observation.
Yeah.
And actually, that whilst these kind of equations can lend themselves nicely, like to developing a data neatness,
Yeah.
it can also lead you off on a slightly wrong curve.
And then there's one more point, which is pretty key, I think, to this balance test. That's it's not a quantitative analysis, like we don't have fixed numbers like nanograms per milliliter. It's a relative analysis, like percentage, right?
Yeah.
So actually, we look at the difference in size between the arachidonic acid peak, you know, the concentration, and the EPA concentration, the omega-6-3 ratio. And this kind of relative measure, the consequence of this is that it doesn't really matter how much blood you have, right? In all type of analysis, you actually need to know the exact amount of blood, which is kind of hard when you collect blood at home, ship it to the mail and so on, you know? Things will happen. People sample with different quality. But the relative difference, you know, will always be the same. So if you have a small sample or a large sample, the relative number will be the same, no matter what you do.
Actually, that reminds me, one of the first times we met, that was some of the data that we went through together.
Yeah.
You were showing me those, and that's like remained with me ever since, because that's such a kind of key aspect, because that measurement, the human part, wherever there's a problem in data, it's the only where humans interact.
Yeah.
That's the only way you start to get an inconsistency, and so that really does address that in such a neat way.
It is.
But I think the conversation's gone immediately now. It's blended into where I need to bring you into this, Emily, because the minute ratio is mentioned, your face is in my mind. So tell us a little bit about the omega-6-3 ratio and how we kind of consider that and how we place that. And maybe just give some clarity around that and explain what it isn't as well as what it is.
Absolutely. But first, I would like to just mention that everything we do here is because we know that fish intake is important. It's the omega-3 fatty acids from fatty fish that we know from so many studies and from population studies and community data is beneficial for your health. And instead of asking people what they eat and try to record it, we want to be able to measure it to see if you are absorbing the right amount, because you can eat the same amount of fish as I do, but have different values because we are different on the inside. So that's what we want to measure. But some people can be interested in just looking at those omega-3s in your blood, and you can do that. But there's also this long history of looking at the ratio of omega-6 to 3. And there is actually 3 different measures that have the same name, omega-6-3 ratio. So I would like to clarify that as well. But this long tradition of looking at 2 specific omega-3, one specific omega-3 and one specific omega-6, and see the ratio between them and have that as the marker of a more healthy population. And that is used in high fish intake populations. So in Japan, we have that, the very early studies as well. So this marker that we use, that is our omega-6-3 balance ratio, is used across the world and in many research papers. It's a well-established marker. But then we have what I call the dietary ratio, which is often used in the diet study when you ask people, what do you eat? How much omega-3? You ask what they eat, and then you have a data program calculating your omega-6-3 ratio, the same name, but different fatty acids.
Yeah, very different measure.
Yeah, so it's the shorter omega-3, the ALA and the LA fatty acids that is compared against each other. And then the third ratio is when some people think it's better to calculate all omega-6 and compare that to all of the omega-3s and have that ratio. We know that there are some weak points to that, but having the two most biologically active and relevant fatty acids against each other is the best method in blood, and also have a lot of research to it. So hope I answered the question there.
I think you did, and I think it's a key point to note is that nothing in the body happens in isolation. And so when you look at these, which are, definably the most biologically active, which is the AA, EPA, and then you work a ratio around them, that's far more really of a mechanistic insight as to the activity that's going on between these fatty acids, rather than that's simply just summarizing how much of a thing there is. So where do you think, just on this, where do you think this research is going to take us in the next, not just the research that we do, which we'll come to in a moment, but where do you think the broader research in this area of the ratio is going to take us in the next 5 to 10 years?
Oh, good questions. There's so many things. I don't know where to start, but continue to map out the ratio in different population groups.
Yeah.
Just continue to contribute with this base, the reference values that we are actually doing together now, and many people, many researchers are interested in to have from one and the same lab. That's also a big part of the benefit. But to be able to add more questions in our database will also help us be more precise with exact dosing. Do you need different dosage in different countries or regions that have a different background diet with more omega-6, for example, arachidonic acid high in their blood? Will there be a difference to have a bigger dose or not? So that will be a big focus.
I know there's something that you're really passionate about, because you mention it a lot, which is this, like a normal population. What does a normal population look like? And that's really interesting to us, is to map that. And I guess we've kind of started that with the first papers, to have a look at how the world is. So would it be fair to say that maybe in the next 5 to 10 years we'll have a clearer perspective of what is normal, rather than what's common? What is normal across it? And obviously something we can come to in a minute. We hope to contribute towards that knowledge and that understanding. But do you think that, well, let me phrase it differently. What's the real relevance of that? When we know what normal is, and we've got this really good reference table, how does that help us, not just from a research point of view, but from a population point of view?
So when we know, for example, that children have different levels, even though they are the same as their parent, high fish consumer, or get high omega-3 levels in them, they still have a natural variation. They still have a natural different level of, for example, arachidonic acid in their bodies, because their cells are maturing and dividing in another rate than for us. So, for example, it's normal and good for them to have higher arachidonic omega-6 fatty acids, even though at the same time have high omega-3, but they can have higher and still have good reference values. And knowing that and be able to account for that in our test is also safety for them, not to overconsume or think that they don't have good values. Same goes for other sensitive groups. Pregnancy, for example. Being able to contribute what is normal in each trimester when you have high fish intake.
But this difference between individuals, it's pretty natural, isn't it? It's because we are different, right? On the outside and even more on the inside. Genetics, right? Enzymes, uptake, maybe even the gut health, uptake of the lipids. And isn't this actually the reason that we measure in each individual? Because it's not like one dose fits all. You actually need to measure, right? To find if people have the optimal concentration in the blood.
Exactly. So the measurement is absolutely for before and after, and also to see if the diet you eat or the supplement intake you have, does it give effect? Is this effective at all? To also be able to confirm that, see the thing happen, but also know when you don't need to push yourself anymore, when you are in a good space.
In the interest of broadening the conversation out just a little, I think we should keep in mind that whatever we define as normality here today is not necessarily normal in a historical context. And one of the things that we know has changed really since World War II has been a progressive move towards ultra-processed foods, which has coincided with a decline in average health expectancy. So what we're seeing today, particularly in populations in the temperate zones, is a population who I think that many nutritionists who say are already compromised. We see that in public health. And when we design policy guidelines and make recommendations, I think it behooves us to keep that long evolutionary and historical perspective in mind, perhaps a geographical element as well, because it's very clear that you can modify the inflammatory cascade in many different places. I mean, yes, the omega-3s and 6s are important, but we can prevent the inflammasome from assembling. We can prevent lysosomal release of various particles which are going to contribute to destruction of the ECM at the very end of the cascade. We can down-regulate the genes that code for those enzymes. So there's many different points of access, which we know about, and actually our programs are designed to modify as well. And I'm hoping that as our research deepens and widens, we're going to start looking at some of those other ingredients in the inflammatory cascade as well.
I think, though, I just want to bring this back, actually, before I move on to, I want to ask some questions about a different test. But I think that as a guiding mantra, what does normal look like? I think that is so relevant in the modern world, which is to take stock of where we're at. Let's look at what is normal now, what is reality now, and then from there, base decisions that move us forward. And with that notion of moving forward, Martina, obviously, the gut health test, which you pivotal to the development of. Tell us a little bit about the research and the thinking that informed that test, because it's decidedly different to what a lot of people were familiar with, the type of test. But perhaps they shouldn't be. But maybe it shouldn't be such a surprise. Maybe if you can just give us an insight to really what informed that type of thinking.
So there are many reasons for why we chose the path that we chose. Part of it was deliberately because we wanted to have a different type of test that doesn't require stool sampling, for obvious reasons. But there also the notion of what the stool sampling itself provides of information, and the information is valuable, of course. It tells you the composition of the microbiome, but the research also shows that the composition is not always equal to the same outcome. So you can see individuals that have quite similar bacterial microbiome compositions, and still they have different health outcomes. And this naturally then leads us to wonder what is causing this. And this then again led us down to looking at the function of the microbiome. And when you then dive into metabolomics, this is really what that is. It tells us the functional output of the microbiome, because when the bacteria in the microbiome, for instance, are digesting our food, in the process of doing so, they produce these metabolites. And the metabolites then work as signals that interact with both the gut microbiome, but also with the broader host environment, so your body. So instead of then looking at just what is there, we want to look at this signal, because that's really where the physiology is affected.
I've always liked the way you phrase that, which is that notion of tuning into the conversation. So it's not just about what's there, it's about what are they doing, what are they talking about, what's happening in there. And that wasn't just a eureka moment. You didn't think that.
Yes.
So, and I know in previous conversations we've discussed the sheer weight and legacy of the research around this. And I think a lot of people maybe aren't as well. They definitely won't be as up to speed as you are. But give people a little bit of a context of that. One, how long this whole area has been investigated, and what's the kind of volume of research that's in this area?
Yeah, so the thing is, with the test, we are looking at these signals, but we are looking at some specific signals from tryptophan metabolism, which is a very well-known biology, and it has been studied for decades. Mm-hmm. But it's now in the recent years that it has been connected to the gut microbiome. And really, the research here has exploded these last years. And especially when you then dive into these metabolites like IPA, I think just from 2020 to 2025, there's been almost 700% increase in publications in that area.
Which is incredible. So, because that's just remarkable. So, I mean, literally that sheer volume of interest. And this comes back to your area, Thomas, really. A part of that surely has to be because of the advancement of the tools, the technology that enables to measure those spaces, the way that we can actually capture that data now. So there's a logic to that increase in observation, isn't it? It's not just because a lot of people suddenly decide they want to look at it.
No,
of course. So it's on those lines. And I remember in the period of developing the test as it is now, you know, Thomas, you kept coming out with new ideas every week about there was something else we could add, and there was a different type of analysis and all the rest of it. So if we can just really, I'm going to bring you in a second. If you just take a snapshot now, final comment on really what informed where we're at, and then Thomas, I want to give you an opportunity to speculate on where we might take the gut health test, because you've been analysing that database, and you know we've done so much learning from what we've observed. But if this was your elevator pitch and you'd say to someone, the research in this area has exploded, give me the elevator.
Yeah, so the main reason why this research has exploded is because the tryptophan metabolism is so central as it connects the gut microbiome with our immune system and also our metabolism. So these signals from tryptophan metabolism is a very interesting way of capturing this whole interaction. So we're not just measuring the microbiome composition or the gut itself, or we're not measuring the immune system itself or the metabolism in isolation. What we're doing with this test is looking at the interface between them.
And I think that's what makes this test so very profound.
Yes.
I mean, there isn't any single analyte or even group of analytes that we can look at which will tell us about something as important as health expectancy or life expectancy. But I tend to think, and we've had a discussion about this, that this particular probe comes about as close to that as anything else I know of. How do you feel about that?
I think it's very interesting, and I think the research area is moving so fast that we're going to get a lot of answers quite soon. And also just this, the fact that this metabolism of the tryptophan metabolism is also so sensitive to diet and lifestyle makes it also a very valuable readout of understanding how different individuals respond to their diet and lifestyle choices, because like we said, everyone are different and we don't respond similarly to even the same inputs.
Yeah.
And also to remember that the big part that the fiber plays for these values. I remember just from both learning and teaching at the university in nutrition and how we can measure it objectively, which there's not many ways to measure if you have been eating fiber and if you are a responder or not. So for me, it's huge that.
Very, very important. And given the depth and the strength of the relationship between fiber intake and subsequent disease risk and indeed mortality. And this is clearly a very important nexus.
I mean, we're living in the age now of what people call fiber maxing. And for decades we've had this approach towards fiber first. Think about when you're developing your plate, fiber first, and sadly, some of the statistics don't support that across populations, but knowing is a great way to empower change. One of the things I most dislike from scientists is when they say, why don't I know this? But one of the things I've always enjoyed about you, Thomas, is that you are one of those people who's continually looking for that thing, to find out something that they don't know about. And so in the context of what happened with the test and where it's at today, and every time I speak to you, there seems to be something else we can do with it. What would you think would be the next step for the gut test as it exists today?
And just want to comment, we say that all people are different. Some people are not, right? Because we have twins, right?
Yeah.
And one-egg twins are supposed to be identical, at least the genetics, right? And this is what we usually regard as identical, kind of, But I think the gut test touches up on something else, the microbiome, because even in one-egg twins, the microbiome is very different, right?
Yeah.
Depending on how they live and what they eat and what they have been exposed for. So I think this test is cool because it's kind of looking at differences in twins as well,
Yeah.
I think that's a nice part of this test.
Yeah, and I think that's also part of the value because, we know how much of an influence our dietary habits has on shaping the microbiome and the environment in the microbiome, and also, of course, our lifestyles. So this is a way of capturing this environment and the influence the diet has on it.
Which is a nice extension, I think, compared to genetics. But it's complex, right? The body is complex. The microbiome is extremely complex. And the output from the microbiome, to the blood, is also much more complex than what we or Martina is looking at now with those 5 metabolites. So there is much more to do. And I think Martina knows very well that a part that haven't been touched up yet is the serotonin pathway.
Yes.
So maybe I could invite her to say something about that. And the brain, right?
How far do we go? Yeah. I think that's given enough of an insight as to what things might be considered as we move forward without giving too much away. But it is, and I think, my comment would be, before we move on to research we're doing and research we aim to do, my comment would be that, a great ambition was fulfilled when we launched that test. And not only how it serves people, which is really powerful, but also the insights it gives. And that in itself is kind of priceless, because it moves not only us together as an organisation, but it actually moves the whole area of science forward, because it allows for far greater insight across the board. And that's a nice way to lead into, I guess, what's coming next from a research point of view. Everyone here is actually on the Scientific Advisory Board, which is really useful. So we all know what research plans we have or that we're doing. I know exactly what everyone's doing. So I think it's, let's just give a little bit of an insight. I think we'll start with you, Emily, and then yourself, Martina. But obviously, Thomas and Paul, you've had already your eyes on these. Do you want to give an update with regards to the current research papers that you are spending all the hours on getting across the line?
All the hours, yes, in between all the other tasks, absolutely. So the second paper we're working on and have our focus on different supplementation group. You can be non-supplement or a generic, the other supplement group, or being a part of the Cincino program. It is a program, so it's not only a product. It's the whole setup with the feedback, with the testing, having a specific number of days to get the feedback, having someone that helps you understand the feedback, and all of this is a successful concept to bring such a big group into more higher omega-3 levels, which gives a balance. And that is what the paper 2 is about, and it's a lot of data, a lot of analysis, and it's good progress soon.
Soon. That's the magic word. Soon. Martina, soon. Do you want to give an insight to what it is you're currently working on, your work in progress?
Yeah, so with the new test, there is also a new database. So from the gut test, we have now accumulated quite a large sample size of tests. So that's what I've been working on analyzing. And it's very interesting because it allows us then to look at how these metabolites behave in a large scale, real world data set of real people out there. And we can see how it relates to their dietary habits, their lifestyles, and different forms of supplementations. And so we can both then be able to see these large-scale population-level trends and how it behaves, and especially this balance between these different pathways within tryptophan metabolism. And then when we dig even deeper into it, we are able to look more on the differences on individual responses and trying to find answers to why there are these individual variability that we see. Which also helps explain a lot of the observational studies we see.
So they're imminent in one way, not to put any pressure on. I know it's soon. I'm going to just step back because Paul, you, like myself, you're one of the kind of gatekeepers. You and I receive a lot of requests from institutes and medical, clinical departments who want to do a type of research. And it's kind of, it's upon us really. We kind of partner a little bit in the decision making as to what research we support. I think the key point I want to make here before I start to talk about some of the partnerships that we've taken off the ground now, we don't just support research that's directly in line with what it is we're about as an organisation. We do actually support research activity that is looking at the wider potential and impact for what we do. And so without us getting too lost in that side of it, I guess, what are your thoughts on that? Because a lot of it actually comes to you and then to me. What are your thoughts on that? What have you noticed change over the past few years?
I think what I see happening is a wider awareness amongst the general community of clinicians and clinical scientists of what it is we actually have to offer. And judging by the approaches that I get, and I'm sure that you get these too, is that they are seeing remarkable results in friends, family members, and often in their patients that they have not witnessed before when those patients were solely under pharmaceutical management. So they then become very interested, and they want to know exactly what is it that we're doing to their patients, and can it be measured? Because as a scientist, you see a couple of cases, if you have a handful of case histories, it's not worth very much. We want to sort of hammer that data out on the Procrustean bed of a prospective randomized clinical trial. And the people who come to us, they have their own particular interests, and sometimes they overlap to a large extent with what we are doing. Sometimes they have an interest which is actually relatively minority. And we may still want to be involved in that, even if it's not very commercial for us, because we happen to think it's a good research project. And I mean, I'll mention just one, which I don't know if you're familiar with this one. This is Judith, who is she's very well respected hand surgeon. Now, if you know anything about the surgical hierarchies, brain surgery is at the top, but hands come pretty close after that. So this kind of very fine work that you do, she's extremely, as I said, well regarded. She's been doing this for 20 years, and she contacted me because she has a significant population of patients who have hand pain. Now, they don't have necessarily rheumatoid arthritis. We don't want to find ourselves in a clinical trial where we're demonstrating clinical endpoints that would lead us into this messy regulatory area where we cannot go. So the criteria that we're looking at are people who've got hand pain. Typically it's bilateral. Typically it's involving multiple of these very fine joints, which may not sound very severe. But of course, when you think about what you use your hands for, it means that you can't necessarily type, you can't use a knife and fork. It's really debilitating. Now, there are ways of measuring this. There are grip strength, and there's pinch strength, and there's key pinch testing as well. And all of these are validated systems, they're widely used. And so at the end of the day, we will have numbers, and she has a large number of patients she wants to put through this. At the end of the day, we will have, I think, a paper that says this is something that reduces hand pain. Now, hand pain is not a disease. But amongst the community of rheumatologists, they know very well what this is. And what they will then do is to take this idea and it will spread laterally within the ranks of rheumatologists.
Well, I think that's a really good example that it's not, directly in line with what we're about as an organisation. We're very much focused on wellness, but where there is a potential for research observation that's really, hyper focused on something they want to look at. We support that in the broader context of, valuing the academic and the research community. And I guess I'll finish this by just, explaining how our strategy works. So we've initiated some partnerships with some leading institutes. We've commenced one just recently with the University of Bath. We've just had an approach from Oxford Brookes University with regards to a research project. We've done work in the past with Liverpool John Moores University. We've worked with independent specialist labs, particularly on the development of the gut health test. And those networks are growing. And the work that we're really hyper-focused on is quite simple to summarize. We want to look at what are the wellness benefits, what is measurable, what is new normal in the context of what it is that we can offer the world. And as always, we always utilize our database, which is the largest database of its type in the world, to draw out insights and information that we think is benefit to the wider academic and even just health populations. So we've taken huge strides in the recent years to formalize a research strategy. We want to make sure that whatever we offer is best in class, fit for purpose, and targeted towards supporting people where they are, to help them where they are to make decisions that they can utilize in the context of their own lives. Our objective, our focus is wellness. It's living well. That is our objective. That's what we focus on. That is our kind of key ticket to the world, and that's what we shall remain focused on. And so, to conclude this and wrap it up, I just want to thank you all for taking the time to travel here and to be here from multiple flights and trains and planes and automobiles. So thank you all for being here. I hope it's been useful for everybody who's listening to this. And I dare say that before too long, we'll do something like this again soon. So thank you all. Well, for me to really explain that to you, we have to understand a little bit of the journey that the fish oil goes on, right from capture to the bottle. And really, it's all about recognizing what can interfere with that fish oil. And typically, from the moment it's been caught and you start the processing, it's anything that relates to light, to heat, and oxygen. So the more efficient that process is, the more intact the oil is when it reaches the bottle. And let's pause for a second and think about the bottle. Even the Balance Oil bottle was designed with purpose. The color of that bottle is to protect it even more from light. But then, let's get real. What do we have the fish oil encapsulated in? Well, it's in that extra virgin olive oil. That's high phytonutrient substance, which in itself is active within the body. But in the context of Balance Oil, it starts to trigger a response. Whenever you consume any type of whole food, there is a biochemical conversation that commences from the very first bite. What happens is, let's say you're biting into an apple. This wakes up certain enzymes in the body, in the gut, to say, right, we are ready to receive this nutrition. When you take that first sip of Balance Oil, the extra virgin olive oil, those phytonutrients, those polyphenols, they wake the system up and they get the gut ready to receive. And this is really one of the key features of how we enhance the bioavailability of the Balance Oil. So we have this encapsulated, protected, high-grade fish oil that starts to make its way through that entire digestive process in order for it to be functionally active where it matters most. And this is a key difference. And remember, Balance Oil is not guesswork. Balance Oil is the direct outcome of test work. Currently, we have the world's largest database. We have over 1.7 million independently analyzed and verified samples depicting the whole global scale of omega-3 status. More importantly, it shows for those people who remember a simple thing, which is to take this much oil every single day to change their omega-3 status. We show care, commitment, and dedication to every step of the process, from capture until that first sip. And it's for all these reasons, when we look at the balance of EPA to DHA, the elegance of the formulation when we look at those polyphenols, when you put all of this together in one bottle and you take a dose that is based on your own body weight, and you do that every single day, that's how Balance Oil works.
Hello, I am